Hi, in this video I'm going to show you guys how to use your TI-84 to find the area bounded by two equations. Okay, so the first equation that we have here is 10x plus x squared minus 3x cubed. And the second equation is x squared minus 2x. Go ahead, take out your calculator and put these equations in your calculator. Alright, so follow along, pause the video if you have to. Now, so in the previous video, we already learned that when we are trying to find the area bounded by two equations, two graphs, we have to be careful with which one's on the top, which one's at the bottom. Right? It's always the top minus the bottom. All right, so please keep that in mind. So even when we are trying to solve equations using TI-84, same thing, top minus bottom. So just to be safe, let's go to Zoom and make sure we all have Zoom standard. And we will see the graph appearing in a few seconds. Alright, so that's the blue one is my cubic, which is my y1. Alright, the blue is my cubic graph. And the red is my y2, the quadratic graph. If you take a closer look, you can see that you can see that these two graphs, they intersect each other at 3 points, right? The first one is somewhere close to when x is equal to -2. The second one is when x is approximately 0, maybe. And the last one is when x is approximately 2. So at -2, 0, and 2. That's the x values when they intersect, right? And so later on we can use second calc, and then we can go to intersect to help us to find the points, right? But not now, right? Not now. Okay, so, but I want you guys, what I want you guys to pay attention to right now is, if you look at, let's say, assuming that this is -2 to 0, who is on the top? It's my y2 on the top, right? My y2 is on the top. My y1 is at the bottom, right? So remember that we are trying to find the area bounded. It has to be the top minus the bottom. So what we have to do now for this problem, we actually have to divide that into two parts. The first one is when my y2 is above my y1. So for my -2, assuming that's -2, so from definite integral of y2 minus y1 from -2 to 0 with respect to x, that will give me the first area. Make sense? Now the second part, so assuming that this point is 2, the intersection, the last intersection, let's say that happens when x is equal to 2. From 0 to 2, my y1 is above my y2. So this would be y1 minus y2, and then find the definite integral from 0 to 2. So we actually have to approach this problem separately. Okay? So now let's do this. So let's find the intersection point first. So second calc, go to intersect. My first curve is the blue one. Yes, that's correct. My second curve is the red one. That's good. And the first intersection I'm trying to find is somewhere there, and it turns out to be -2. I'm only interested in x value, right? So x is equal to -2. So later on, when I do a definite integral, I need to start from -2. My lower bound is -2, and let's find the other intersection point. The other intersection point is going to be somewhere close to the origin, somewhere there, and it is 0. Okay, so now I'm not going to use my graph anymore. What I'm going to do now is go out to my calculation window and go to math. Go to number 9, right? Number 9, and then we can find this definite integral. It was from -2 to 0, right? Now, who's on the top? The y2 is on the top, right? The y2 is on the top. The red one's on the top. So make sure you put y2 there, okay? So here you should have y2 minus y1. So go to your bars, go to your y bars, go to your function, y2 minus function y1, and with respect to x. All right, and that gives us 12. So the area bounded by these two graphs from -2 to 0, that is 12. Now we have to do the other part, right? Let's look at the other part. So again, we need to find the intersection point. I know that it's going to start from 0. I just have to find the last the x value of the third intersection point, right? Go to intersect. My first curve is the blue one, that's good. The second curve is the red one, that's good. My guess value is somewhere there. So the third intersection happens when x is equal to 2. So later on, when I do the definite integral, I'm going to go to math, number 9, and it will be from 0 to 2. And that will be, instead of y2 minus y1, it will be y1 minus y2. y1 minus y2 with respect to x. And that happens to be 12 as well. So now what's the total area? The total area will be 12 plus 12, which is, the total area is now 24. So the total area bounded by these two curves is 24. But please be careful. You need to make sure that who's on top of, which graph is on the top, and you subtract the lower one. Okay? So all we have to do is to find the intersection points. Be careful with which graph is on the top, and that's it. All right. I hope you guys find this video helpful. I'll see you guys in the next video. Bye.